So in this problem, we start with that Udacity example of reading a bunch of picture objects, and then we're supposed to find the largest one, meaning the one with the largest area. Say that's this one, and then we're simply supposed to cover that one in black. So clearly the key part of this assignment is to find the picture with the largest area. So how do you find the largest one of anything? Well, in the textbook we have an algorithm for finding the maximum and minimum, so we obviously need to adapt that algorithm. The algorithm here was written for numbers, not for pictures. So over here we find the largest number, so we're going to have to change that to say we want the largest picture. Also, we're finding it in an array list and not in an array, so we have to use the .get notation. Over here, then it'll also be .get, and here it'll be .get. And here in the comparison, we have to be a little bit careful, because how do we compare two pictures? We now have to compute the area of the ith picture with the area of the largest picture. So this largest here, we really have to compute the area, so that will be largest dot. Unfortunately, there's no get area method, so we have to do get width times get height. I better just show you this in code. So over here, we're computing the area of the largest, and over here I've taken that out as a separate line. It was getting too complicated. I'm computing the area of the ith picture, and I'm putting that here out in a separate variable because I need it here and in three places, here, here, and finally over here. So it's basically the same algorithm, just changed from numbers to pictures. So why is it in the book with numbers? Well, the numbers are the simplest way of understanding the algorithm, and then it's just your job to adapt it to other situations that you might have, and work with the fact that they're objects, that the comparison over here then may be a bit more complicated, and that's just the way it is. We describe the algorithm in its simplest possible way, and your job is to adapt it to more complex situations. I could have simplified this particular algorithm a little bit, because with pictures one can actually, since the largest possible area is 0, you could write it in a different way. Just to show you that this is more than one way of doing it, let me do this. So what I could do is I could store the largest area that I've seen so far, and say the largest area so far is 0, because areas can't be negative. Then over here I could just use an enhanced for loop. Then I wouldn't need this stuff here. Here I would compute the area. Now here I've already computed the largest area. And then if I found a larger one, then I would remember the largest picture and the largest area, and it would also work just fine. So this is something that you often see as another adaptation of the algorithm for finding the maximum, that one keeps track of both the largest item and its measurement and updates those through the loop. The remainder is simple. It simply fills the thing that's now known as the largest. I guess somewhere I needed to declare it too. Picture, it's a picture. And at outset we can set it to null, because as long as this array is non-empty, it'll be immediately set the first time around. Alright, the other thing that I wanted to talk about here is how you can test these kinds of things in BlueJ. There's a bit of a twist to this. When you ran it through CodeCheck, then what happened is that CodeCheck entered some numbers, and that caused the gallery to be populated with some pictures because of the code of the runner, and then it entered a different set of numbers, and so on. Now how can you test this without CodeCheck? Let's see how this goes in BlueJ. So here's the runner, And so when you look at it, it sets up a scanner that reads from the console, and then it checks whether the next number is an integer. If so, it reads it in, adds the corresponding thing to the gallery, draws it, and calls remove largest. Now when we run this program, what's a little disappointing with BlueJ is exactly this. You don't see what's now happening. It looks like the program died. So when you go and see the terminal window, here it comes, then that's the window where you can actually enter some stuff. So now let's enter 1, 2, 3. Well, how are we going to get it to stop? Right? It keeps being in this loop while there is another input, and it doesn't ever draw the gallery until this loop has been exited. So we need to have some way of exiting this loop, and the way to do that is to give some input that's not an integer, like Q or Fred or whatever, it doesn't matter. And now this works fine. So the loop has exited, the diagram is drawn with the images, and hopefully this was the largest one. Now this is something we could run through the debugger and see whether that really was the largest one. In fact, why not just do that, just that you know how that works. So I set a breakpoint here. I run one more time. So let me stop this one here. One easy way of stopping it is just to hit compile again. The other way of stopping it is to right click on this thing here and set this, whatever it means, the reset the Java virtual machine. So we're going to run this one more time. Now it asks us again to enter those numbers. And here we are, ready to step into this method. So let me step in, and so now it tells me that the area of the first one is, where is it? Largest area 12,600. Is that believable? Let's see whether we can see our array list here. And we can. I can actually inspect it. And here's my first element. I can inspect that. And now what I would want to do is I want to call a method on it. And it won't let me do that. Hang on, there is a way to do this. No. Okay, that's unfortunate. So I don't seem to have a way of calling that method. So we need to verify that later. So then when I step the next time, you can see how it now finds the next area. The largest area was 12,600, and now it finds an area of 12,769, and that's larger. So that way you can debug this. Now to really see that it's doing the right thing, it would of course be kind of helpful to actually know how big these pictures are. So I guess for that we need to just look some picture viewer. So I happen to have one here. So here was the first one. Here was the second one. It was 113 times 113 pixels. And that is in fact 12,769, which is the number that we've seen here. So the program does seem to be doing the right thing. So it's a really good idea for you to be familiar with the debugger, to know how to step through these things, how to read the various areas of the display. And as I believe I've mentioned a couple of times, this will be tested in the exam.